If you head into the resources section, you'll see there's an Excel spreadsheet, so you can go ahead and open that up, and you can also open up the Logisim file. Now within the Excel spreadsheet, we've seen this tab here before, Special Cases 1. So we use this in order to generate all of our special cases. Now there's an extra tab here called Special Cases 2. So in this tab we've got a copy of the X input for the special cases, the Y input for the special cases, the expected result from addition and the expected result from subtraction. Now what we have to do is we have to populate these with the actual numbers for nan, plus infinity, plus 0, minus 0, so on and so forth. So I've done that within this little bit of code. So when you click on the go button, it just reads these and it puts in the correct values into these columns. So that's it, populated these columns. Now what I do is I take a copy of the X values, so there's 45 of them, Control C, and I place them into a little file. So the file is called x_sim, and you'll see that in the resources section. So as long as the file is appended with this raw v2.0 space raw, then Logisim will read it. Okay, so this is all our X inputs, and I do exactly the same thing for the Y column, and I create the little notepad here with the Y values. So what we're going to do is we're going to read those into our Logisim file. So if you go ahead and open up Logisim, now what we can do here is we can make sure you're on the actual simulation, and we can right click this, edit contents, and we can open up the file. So we'll just head back up and I'll find that file. So the file for the X values is x_sim. So I can open that up and you can see it's populated those here. Close the window and then you can go into this one here and you can go edit contents and you can open up the Y values. So that's y_sim. And of course you can get these for the resources section and you can go and load them in yourself. Now what we can do is we can work through each of these individually, and what it's going to do is it's going to give us the flags and also the number types here on the left hand side and the right hand side. So these values here should match up exactly with the values that we have here. So for example, in this column here, this is the expected result for addition, and I've got in this column here the actual result for addition. Now I've got here the expected result for subtraction and the actual result for subtraction, and I've compared each of the subtracting columns and the adding columns, and I've just checked to make sure that they're all true, and I went through all of the examples here and you can see that they are all true. So all of these actually work. So if we were to look at the first one, for example, if we had the plus infinity, then we should get a plus infinity out, okay, for the first one, and then a nan, and then 1, 2, 3, 4 plus infinities. So we'll have a look at that. So plus infinity, nan, and then 4 plus infinities. So if I click on these, the little block here, so we can see it starts off with plus infinity, and when I click on it here, it goes to nan, and then it goes to plus infinity, plus infinity, plus infinity, plus infinity, and then it goes back to nan. So if you were to work through the entire lot of these, okay, so there's going to be 45 of them, so you could continue working through these by yourself, and you'll see that it jumps through each of these flags, and all of these flags match up with what we have in the Excel spreadsheet. And whenever we're working with a number, say for example 0 plus a number, we just get the actual number coming out, then we don't get the special case, we just get the number type here. So in this instance here we have a normal plus a subnormal giving a normal result. So if you want to, you could get into the simulate and tick enable, and it will just run through, and it will just continue running through it. It's in a repetitive mode. So you could simulate, you can stop that, okay, and you can get into here, you can get the results. So if you go edit and you can save the results, you can see all the results here. So you can save these results in a file. Now I've gone ahead and I've obviously already done that, and I've saved the results in a file called add_sim and also a file called y_sim, and I've used these in order to compare the actual output with what we expect to get. So I took a copy of the values here for example add_sim. So this is the actual results coming out from Logisim, and I've done the same for the subtract here. These are the results for the subtraction of those 45 values, and I've been able to compare them within the spreadsheet. So I just make the comparisons here, and everything worked out fine as we expected it to work out. Now, as a final check, what we want to do is look at the interface between the different number types. For example, we're going to look at the smallest subnormal number, we're going to look at the largest subnormal number, the smallest normal number, and the largest normal number. And we're going to see that whenever we add and subtract the numbers that are on this interface, that we get the right answers, because this is going to test whether, it's going to be a good test to see whether the adder and subtractor actually works for these number sets. So let's put in a few of these just now. Now I'll just pop them in here. I've got a copy of them here at the moment. So if I go in and we can project and we reset the simulation, and we can put some of the numbers in. So for example, if I was to put in the number 1 and also the number 1 here, so these are the two smallest subnormal numbers. So obviously whenever I add them together I get the result, and the result is going to be a value of 2, which is what we expect. Now whenever I subtract them we should get a value of 0, which is what we expect. And you can see here we've got the +0 here for that result, and we've got the subnormal plus a subnormal giving a subnormal result. Now we could also put in, say for example, we put in the value of 1 there and we put in the value of 2. Then we could have 1 plus the 2 will give you the 3. Now if we had the 1 and we subtract off the 2, we're going to get a -1, so it should go down to the minus the smallest value. And you can see here that's what it's gone to. We've got the value of 8 in the first bit here, so it tells us that it's actually a negative and it's the smallest value. Okay, so we'll head on, we'll try a different interface. So we're going to look at the interface here between the largest subnormal number and the smallest normal number. So what we can do is we can put in the value, for instance 007123455. So that is the largest subnormal number. So if we were to add a value of, for example, 1 to that, then what we expect to get whenever we add this on is we would go from the subnormal range and we would add in this other subnormal number, and then we would get into the normal range. So this is just the number that just takes us from the subnormal range just into the normal range. And you can see that here we've got a subnormal plus a subnormal giving us a normal result. And the result is the correct one. The 7 all F's go to a value of 8 and all zeros. Now we could go the other way. We could go from the smallest normal number and we could subtract off the subnormal number. So we could put in, for example, 00845, and we can subtract off the smallest normal number, so that's that value. So if we were to add it on, you can see here we get the value of 8001, which we would expect. Okay, now if we were to subtract it off, and in that case it's a normal plus a subnormal giving a normal, And when we subtract it off, you'll see here we've got a normal and we're subtracting off the subnormal and we're getting a subnormal result. And you can see here we've got the required subnormal result here. So finally, if we were to add together two large normal numbers, so for example we take the largest normal number, which is this one here, and we add it to itself, it should overflow to plus infinity. So I'll put those numbers in just now. In fact, you can see them here. We've got 7f7 and all f's, 7f7 all f's, and when we add them together we overflow to plus infinity, which is what we expect to see. Well done if you managed to get to the end of the course and you got your adder and subtractor to work. In the next course we're going to go on and we'll do the division and square root. So thank you for taking the course. Good luck and goodbye.